phenomenon is the blue lava at Kawa Aijin. Our overarching concept for this unit is going to be balance. Our essential question is looking at, is balance necessary and can it be achieved? Our focus questions for today, so by the end of the day you should be able to answer these questions. What are natural resources? Are natural resources distributed equally? Are they balanced? Because we're talking about balance. What are the current and past geoscience processes that result in resource distribution on the earth? And what are the effects of this resource distribution? Okay? Mere words.
Mere words.
Natural resources.
Natural resources.
What we need.
What we need.
In order to survive.
In order to survive.
What we need.
What we need.
In order to survive.
In order to survive.
Two types. Renewable.
Renewable.
Non-renewable. Renewable.
Renewable.
Non-renewable. Mirrors off. Teach.
Okay. All right.
evenly distributed? So is the sunlight evenly distributed around the earth?
No. Wait.
No.
That's why we have deserts.
Okay. Kristen, why do you not think the sun is evenly distributed?
We got
Kristen.
nighttime. We got nighttime. We have nighttime.
Okay. Does everyone have equal amount of day and night?
Oh, yeah.
Okay. So why else would?
Technically, we don't.
How so?
What's it called? What's daylight saving
Okay, but we're still getting the same amount of daylight as everyone else in the world on a specific day,
Oh yeah.
right?
Yes.
So if I take a calendar year, 365 days, and divide out how much sunlight we've received versus how much sunlight someone in Australia has seen, are we going to have the same amount of time?
No.
But are we going to have equal amounts?
No.
Oh yeah.
What if you lived in Antarctica? Do you get the same amount of sunlight as someone who lives in Louisiana?
No.
Why?
Because Alaska has a whole big
Be confident. When the northern hemisphere is tilted toward the sun, it's summer for us. It's what for the southern hemisphere? Winter. There you go. So, who's getting the most direct sunlight during
The northern hemisphere.
the northern hemisphere? So, are we getting the same amount of sunlight as, say, Antarctica during this time? No. What about during our winter, when we're tilted away from the sun? Who's getting the most amount of sunlight then?
The southern hemisphere. The southern hemisphere.
Well, the southern hemisphere, okay, which would include Antarctica down there. So we're not getting equally distributed sunlight all year. Question. Antarctica. What about water? Does everyone get equally distributed water?
No.
Jimmy, why?
The desert.
The desert. So the desert gets what? Little light in
Little
between?
water.
Little water.
Got the rainforest. Some days.
There you go. So you got the desert, which gets very little water, and the rainforest, which gets a whole lot of water. So there, we're not equally distributed either. So renewable resources are not distributed equally around the world. What about non-renewable resources?
No.
Why do you say that?
Because in some places you'll find a lot of oil.
Like what kind of places would you find a lot of oil?
Iraq.
Louisiana.
Iraq.
Places like
United States, Louisiana.
Iraq.
Okay, so Louisiana does have some, but where has more?
Iraq.
Okay, Iraq, Iran, over there in the Middle East. Okay, they're the ones with the massive amount of oil reserves and oil deposits. Okay? So the United States does have some down here in Louisiana. Where else in the United States do we have?
Along the coast.
Yeah.
Coast.
Along where?
Utah.
The coast of, not Tennessee, up further north.
West Virginia.
No, we're going to talk about
Pennsylvania.
Alaska. Okay, so we have unequal distribution of oil and petroleum. What about coal?
That's like I don't know where.
Does anyone know where there are lots of coal mines?
Like more the land there.
There are some in America. Do we have coal mines here in Louisiana? No? Anybody ever heard of the coal mines in Virginia?
Yes.
Hawaii? No, it's not. Okay? So those fossil fuels are not equally distributed. Oh, yeah, you keep that. And so non-renewable nor renewable are equally distributed. So what does that mean for us?
We have to split it up between all of us.
We have to split it up between all of us. So if the Middle East has all of this oil, how are we going to get it here in America? Because what do we turn oil into? Gas. And we need gas to drive, right?
Right.
We have lots of vehicles here in the United States. So what do we do to get the oil?
We steal it all.
We make allies. We make allies.
We trade.
I just said that.
Okay? So this unequal distribution of our natural resources causes countries to have to work together. What else? Think way back when the Europeans first started settling in the United States. Where did they settle?
The west. I mean the east. The east.
They settled in the east. Where did they settle close by?
Pennsylvania.
The water on the coast.
On the water. Why?
Because they had ships.
They went across water, the ocean.
Okay, they needed to fish
Trade
for
routes.
food. They needed the waterways for trade. Okay, so where we build cities now is based upon what?
Where
The land.
Where it's located in the land, the natural resources that are occurring there, right?
Yep.
Why is there not a whole lot of population in, say, Antarctica?
Because it's cold.
Cold, and they have very few resources. The resources that they may have down there are frozen and can't be gotten to. Okay? So, mere words. Natural resources. How do they affect us? Population. Economy. Our money. Whether or not we can trade. Or if we go to war. Natural resources. They affect us. Our population. Our economy. Our money. Whether we can trade. Or go to war. Mirrors up. Turn and teach about how those natural resources affect us. So they affect our populations, our economy, our money,
And when do we go to war?
trading, and war. Teach. Population, you can hear me. Okay, so take a look. You've got 2 pages from back. They correspond together. So page 7 goes with page 19. And what page 7 is, it's giving you some information on how the oil on Earth is distributed around the world. You're going to take this information and turn it into a pie graph or circle graph here. And then the questions below, you'll answer on page 19, below your pie graph. Then you're going to flip both sides over. On the back side, on page 8, you see where all the copper reserves around the world are found. I'm going to pull up a colored map, although the colors and the key below is not important. What you're doing is you're comparing the copper reserves to the plate tectonic boundaries. And then you're going to answer the questions from page 8 on to page 20 below. Okay, give me a thumbs up if you understand what's going on. You understand what's going on? All right, you're working with your shoulder partner. You've got 15 minutes. Hey, if you're not on the back side, you need to be moving on crinkly.
We did that wrong. We did it
We're in
wrong.
the top for reserves council or September. We're in the, even just look where your papers put page, what was it, page 7? 7 on top, make sure both of your names are on it, 7, 8, and then 19, 20, 18, 19? 19, 20, okay? Get those set up. Chloe, can you go around and pick them up for me, please? Chloe's gonna come around and collect them from everybody. We are going to be looking at our focus questions for the day is what is the law of superposition? What is the law of original horizontality? We're looking still at the effects of resource distribution and the current and past geoscience processes that result in this resource distribution. Okay, so I want you to tell me, if you're looking at a picture of several generations of people, how do you tell who's the oldest? What does it mean to look old?
They got wrinkles.
Okay, wrinkles, gray hair, maybe bald, saggy skin. They have crinkly hands. Okay. Okay, so even if you didn't know the people, you could look at a picture of several different generations of people and say, well, this one's the oldest because of these features, and this one's probably older than that one because of these features. Okay? Geologists do the same thing. They can look at different layers of rocks and they can tell you this one is older than that one or younger than this one due to the law of superposition. The law of superposition has to do with the positioning of rocks. Our models that we're going to be building today are going to fall under the law of original horizontality. We're going to form nice, neat layers with our models. However, is everything in nature nice, neat, and horizontal?
No.
What happens to prevent that?
Erosion.
Natural disasters like earthquakes, landslides, tornadoes. There are lots of processes, these geoscience processes that are happening in the everyday we're going to be building models. If you look on your sheet, I know you've only got one per person, it goes through and it tells you your 4 main jobs, and it gives you a brief description of each job. So on your table, you have cards that list the 4 jobs. So as I go through and read your description of your jobs, you are going to decide which person is doing which job. And I want you to put that card on you before you all get started. So the very first thing, again, you have 2 sticks of each color, so you're going to make 4 different layers. My geologic historian, you need to make sure as you're listing your events, everything is a separate event.
Yes, ma'am.
Okay? So if I have my first layer, I'm depositing, and if you see there, it's written right there, deposition of bottom sedimentary layer. And then you need to identify the color. So deposition of bottom sedimentary layer, white layer. Okay, then maybe I have the burial of a leaf fossil. And then I have the burial of 3 mineral ore deposits. Then I have the deposition of my second layer, orange. Okay, every event is its own thing. Make sure you label them individually as you're going down. Give me a thumbs up if you understand. Get it, got it, Can I put the space behind you? Okay, what's the first thing you're gonna do?
stick a straw in the clay.
Take the wrap off.
Well, you're gonna take the wrap off, but what's the first thing you're gonna do before you start drilling? Write the other group's names. So write the names off the plate onto your other's group names. And then you all can start drilling. Don't go just around the edge. Get all over the place. Yeah, leave it on the plate so you don't forget which is top and which is bottom. Make sure you push it all the way down, unless you can. You may hit something and not be able to go any further. You may hit something, so it may not go any further. So then you pull it out, and see, you hit the edge of something, that's why it wouldn't go any further. So for side one, you have four.
Wait.
I got Play-Doh.
Well, it's clay. What is that representative of? Your sedimentary rock layer. Yes. So you went to what layer and fossil.
Question.
Answer. Let's try it again. Sometimes they kind of stick. See, sometimes we have problems with that. So, in the real world, a geologist tries to dig a site, a core sample, and it won't come out. What are they going to do? Okay, so they may try and go around it and pull it out, or they may do what?
Dig another one?
Dig another one. So they hit a spot that they can't go through for whatever reason, so they may try and go close by and hit it again and see if there's something maybe that they can access from that spot. So you're going to be recording right here. So side one, you may put first try, core sample wouldn't come out, second try, and whatever you get from your second try.
Yeah, they showed you
You stop at black. You stop at black.
Okay.
You didn't get past the
And
black.
it could be
Because the
separate.
black is have a hole in it.
Yeah, you can't get it.
I know, but the hole, we don't see it right
Well, she hit a fossil like video. Like, it was red.
All right, class.
They're coming to the other hole.
I know I ain't getting no
Class.
Yes.
You people steal my job.
Stop looking, listen. Okay, so most of you are getting close to finishing up your core sampling. So I'm going to move on and tell you what you're going to be doing as you ask. If I am using their model here and I dig up my top layer, is my top layer, where is it going to go in my geologic history? Am I going to put it on number 1?
No.
Why not?
Because it's the last one. It's the oldest one.
Because it's the newest or the youngest one. Remember, who gets to that football first? The person on the bottom or the person on the top? The person on the bottom. So in your model, the layer on the bottom is the oldest, but we can't dig from the bottom up. We dig from the top down. So as you record your geologic history, you're going to be recording your geologic history from the bottom up. Because the very last thing that was deposited here was this red sedimentary layer. So that'll be their very last sequence of events, okay? So as you are digging, make sure you're recording from the bottom and going up as you do go. Make sure each event is its own separate line. So if you have underneath my red layer, say I have a mineral ore deposit and a fossil burial, then number 9 will be deposition of the red layer. Number 8 will be burial of my fossil. Number 7 will be mineral ore deposit, and then I'll have deposition of my next layer for number 6. Okay, give me a thumbs up if you understand. You know what we're doing? All right, so when you're done taking your core samples, go ahead and start digging up your model.
I'm digging.
See if you can find any fossils.
It's like the bistro. Put it in the middle, see what
Dude. You might as well just pull it out that side.
I mean, Jamar ain't here to find fish.
So what's going to be your very last step? What's that?
He got all those.
Color.
Oh, I got
What's going to come?
Just push it down.
Deposition of sedimentary rock peak. Okay, so let's take a look at our wrap-up questions here. So number one says, what geometry do sedimentary units form in?
Flat.
They're flat. Okay, all of our layers were very flat. Is that going to be true for metamorphic or igneous rock? No. Why not? Why is it wavy?
Why is what wavy?
Metamorphic rock?
Because it's hot.
Because it gets hot and it gets what?
Into diamonds.
It doesn't necessarily shrink, but it definitely gets crushed, pushed together. Okay? So remember, to go from sedimentary rock to metamorphic rock, what are the two things that we add? Pressure and heat. Okay, so with that heat and pressure, those nice, flat, horizontal layers get crushed together and heated up and bendable until they form this conglomerate, wavy, metamorphic rock. How does it turn from metamorphic into igneous? Where does igneous rock come from? Volcanoes. Okay, so it's heated and melted even more to where it turns into what? What comes out of volcanoes?
Magma.
Okay, number two. Why would the layers on the bottom be older and the layers on the top be younger? What was there first? The older layers on the bottom. Okay, the longer you've been there, the older you are. And the more stuff that gets piled on top and piled on top and piled on top.
Child, you having too much.
Right here. And rocks and layers and people. Raise your hand if you found mineral ore in excavating. Did everybody find your mineral ore? Yes. Okay.
I know we didn't find one.
Raise your hand if any of you found mineral ore when. Raise your hand if you found mineral ore when doing your core samples. Did anybody find mineral ore in their core sampling? Okay, so we had a couple that did. So, what does that tell us about that distribution of those resources? Because I had, out of my 5 groups here, only 2 found mineral ore when doing core sampling, but everybody found mineral ore when actually digging. So what does that tell us?
That is not a lot.
That there's not always a lot, that it can be hard to find